Hello, my name is Gregory Osborne, video game audio composer and implementer, and in this video we're going to take a closer look at linking up the Reaktion library for Unity by Keijiro Takahashi and the audio middleware engine Wwise. If you're new to Reaktion, I recommend checking out my quick introductory video on the basics. The first thing we're going to need to do is to integrate our Unity project with Wwise. There's already tutorials out there for this, so I'll gloss over it. We'll be back later for a more in-depth look at busing in RTPCs. Second, we also want to make sure that this project has imported the Reaktion library, something I covered in the introductory video. I'm going to go back to Wwise and import a basic loop which we'll use for this video. Put it into a playlist container. Make sure that the playlist plays my segment infinitely, and then attach that container to an event we're going to call play loop. We'll create a sound bank, drag the play loop event into it, and generate that sound bank. Make sure to save. Back in Unity, we're going to put an AK bank script onto the Wwise global object, though it doesn't really matter where as long as it's in the scene. And we're also going to create a game object with an AK event object that calls the play loop event on start. Let's press play on the scene and make sure that it works. Let's go back to Wwise. Now for the fun bit. We want to get an input value from Wwise of how loud the audio is and feed it into a reactor component. In order to get that value accessible by Unity, we can use the Wwise meter effect and its ability to output an RTPC value, or real-time parameter control value, of how loud the signal going through any bus is. We can then access that RTPC value in Unity. Now, we could put this effect on the master audio bus. However, that would limit what we could do to the signal before it reaches our ears, because any changes, such as filtering, that we do before this meter would also be played back to us. So instead, I'm going to create a separate audio bus and call it RTPC meter bus. Let's take a quick look at the general settings of our loop playlist. You cannot send audio to two audio buses. However, if you look in the user-defined auxiliary sense, we can send audio to an auxiliary bus that we define. Let's go back to our newly created RTPC meter bus, and under it create an auxiliary bus, and call it meter1 bus. We'll select this bus and click on the Effects tab. In the Effects window, click on one of the arrows, and I'm going to use one of the higher ones for reasons I'll explain later in this video. Scroll down to the Wwise meter effect and create a new meter. Let's call it meter1. Double-click on this effect to open up the window where you'll see a box labeled Output Game Parameter. This is where the meter level gets turned into an RTPC value that Unity can access. Click on the two arrows and create a new RTPC. We'll call it meter1 RTPC. Check to make sure the minimum value is -48 and the max is 0. There isn't an easy way to test that this meter is working though. You'll notice if you select your playlist container and hit play, sound plays, but the meter doesn't change. That's okay, we'll have other ways of testing to make sure it works later. In the Project Explorer, go to the Game Syncs tab and click on the RTPC you just created. You'll notice that its min and max values don't line up with the values it'll be outputting. Normally, this would be fine for game audio implementation, but we're going to want the values to be accurate on a decibel level because that's the range of values that the reactor component takes back in Unity. So change the min value to -48 and the max to 0. You can ignore the dialog box and just hit stretch, and change the default value to -48 so that the first value is always silence. Finally, go back to your playlist container and edit the user-defined auxiliary send so that it sends to the meter1 bus. Make sure to generate your sound banks again, and save your Wwise project. Let's go back into Unity to check and see if things are working. I'm going to write a quick script that checks the value of the RTPC and uses debug.log to put those values in the console window. I'll right-click in the project window, hover over Create, and select C# script, naming it RTPC debug. I'll open up this script by double-clicking on it, which should open Microsoft Visual Studio or whatever integrated development environment you use with Unity for coding. We'll declare a public string called RTPC name, which will later set to the exact name of our RTPC in the inspector of the script. In the update method, first we declare a float called value and an int called type, which we'll set to 1. Then we'll use akSoundEngine.getRTPCValue in parentheses RTPC name, comma, game object, comma, 0, comma, out value, comma, ref type in end parentheses. What this will do is set our float called value to whatever it is the RTPC value is in that moment, and it will run this function every frame. Finally, we'll use debug.log in parentheses value so that we can see what the value gives us in the console. Make sure to save your script. Back in Unity, we'll create a game object and attach our RTPC debug script to it. We'll then edit the RTPC name in the inspector to the name of the RTPC we want the level of, specifically in this case, meter1 RTPC. Let's hit play and watch the console, where we now get values equal to the decibel level of the music every frame. Awesome! The final step of this process is going to be to use this value as part of an injector. In order to do this, I'm going to go into our assets folder, into the reaction folder, into the injector folder, where we'll find all of the injector scripts. Create a new script in this folder and call it Wwise Injector. Open the audio injector script as well as the Wwise Injector script in your IDE. Again, mine is Visual Studio. Copy and paste the audio injector script into your Wwise Injector script. Make sure to change the name of the class near the top from audio injector back to Wwise Injector. Now, the way that the injector outputs a value to Reaktor is by setting the float dB level. In our Wwise Injector script, rather than the calculations it did in the audio injector, instead we're going to replace the update method with the update method we used in our RTPC debug script. We'll add a line before the debug.log line with dB level equals value. Save this script. When we go back to Unity, we'll create a game object onto which we'll add our new Wwise Injector script. This object should now effectively function as an injector. Let's prove that by making a game object and putting a Reaktor component on it, then select bind by reference and drag our new meter1 injector object into the inspector. Next, we'll create a cube and throw a material gear onto it. I'll select a color gradient I've already set up. We'll make sure this gear is referencing the right Reaktor the same way as before with the injector. And when we hit play, I'll adjust some settings on the Reaktor to make sure it's reacting properly. One important way to adjust your settings is to watch the peak meter when you hit play. You'll be able to see a representation of how much quiet audio is gated in white, followed by the green zone where your dynamic range is, followed by headroom in red where only the max value is output. This meter is actually the best place to observe the effects of the fall down value. By default, fall down is set to just 0.5, but because for this part of the demonstration I pretty much always want a large amount of audio reactivity, I'm going to set the fall down speed pretty high so that Reaktor will more closely follow the dynamics of the loop. Just watch out. The setting changes you make while Unity is playing will not save when you unplay. So when you've got audio input option settings that you like during testing, make sure to remember them or write them down before stopping the playback. In any case, it works. The next part of this video is going to be me implementing two different reactors, one for lower frequencies and one for high frequencies. This, I believe, is one of the most powerful applications of our Wwise Injector, because in Wwise we can have one loop send the same information to multiple aux buses and separate out different information from the same music. Not only this, but if we set up our music segments properly, we could even have every segment made up of multiple layers all playing at the same time, but sending different information to different buses that we've set up. Let's start with just the high and low frequency reactors, and head on over back to Wwise. In Wwise, we'll make a second aux bus and call it meter2 bus, and we'll set it up with its own Wwise meter effect called meter2 that outputs to its own meter2 RTPC. Again, go back to the Game Syncs tab and correct the RTPC values. We'll also need to remember to go back to our playlist container and add another send, this time to our new meter2 bus. Now, Meter 1 is going to be our low-end frequencies, so we'll go into the Effects tab of Meter 1, and before our meter, we'll throw on a Wwise parametric EQ. Double-click on this effect, and we're going to use a low-pass curve with a frequency that I've already tested out. We'll go back to our Meter 2 and do a similar thing, instead using a high-pass curve. It's important to note at this stage that we'll start hearing some weird filtering if we don't turn down the audio from our RTPC meter bus. Go to that bus and add an effect called Wwise Gain and then turn the gain all the way down. Audio will still play from our master audio bus as intended, but since we only need the RTPC meter bus for returning values and not for audio, we can send pretty much whatever we want into these aux buses for the benefit of metering and not have to hear it play back. Generate your sound banks and save Wwise, then go back to Unity. In Unity, we're going to duplicate our chain. On your duplicate injector, change the RTPC ID to meter 2 RTPC. You'll notice on your duplicate reactor that it's already assigned itself to the right injector, and the same thing is true of our duplicate cube gear. I am, however, going to move our duplicate cube up a little bit and change its material. In addition to this, I'm going to go back to our fall down values and put them at 0 so that the difference in volume between the two frequency areas will be more pronounced. We'll hit play and see what happens. I'll just point out that on our meter 2 reactor, that because we start off at silence, the peak will start off lower than it will end up after the beat comes in. Once the beat comes in though, the peak value won't come back down, so that when quieter sections come back, the high-end frequency reactor won't output the higher values anymore. Starting your scene and judging things based off of the first couple of seconds can be deceptive that way. Watch for when the music drops in volume again. You'll be able to see the hi-hat pattern be noticeably separate from the bass activity. The final section of this video is going to be demonstrating the ability for music segments to have their individual component music tracks sent to different aux buses entirely. I'm going to do that by going back into Wwise and importing the second layer of the loop into the segment. Next, I'm going to repeat the process of before, adding another aux meter 3 bus, adding a meter called meter 3, and outputting to a meter 3 RTPC. Once again, go back and make sure in your GameSyncs tab that meter 3 RTPC uses the correct values. Lastly, back in the audio tab, we're going to select our second layer, go into general settings, and click on override parent in the user-defined aux sense. Instead, we're going to send only to meter 3 bus. Generate those sound banks, save your Wwise project, and head back on over to Unity. Duplicate your chain one last time. Remember to change the string of the third Wwise injector, and I'm going to move this third cube into the middle and color it blue. When we hit play, you'll notice that this third cube only follows the new layer that we've added. I think this is insanely cool, and I'm going to be using this process in a project I'm currently developing. Subscribe for more updates, message me on Twitter or Facebook, and I'll likely be making more tutorials over the course of this summer showing off cool new interactive audiovisual techniques.